The process of removing a stoplog begins with careful preparation to ensure the safety of both personnel and equipment. First, the area is inspected thoroughly. This includes checking the structural integrity of the stoplogs, the condition of the guide slots, and the functionality of the lifting equipment such as gantry cranes or mobile cranes. It's also essential to assess water levels and ensure that pressure against the stoplogs is reduced, if possible, by lowering upstream water levels or diverting the flow temporarily. Once the area is prepared and all safety protocols are in place, the crane is positioned over the stoplog bay. A specially designed lifting beam or spreader bar is attached to the crane's hook. This beam is equipped with locking mechanisms, such as hydraulic arms or mechanical pins, that are used to engage with the lifting eyes or handles of the stoplog. The crane operator then carefully lowers the lifting beam into the water until it comes into contact with the uppermost stoplog. Using either visual guides, underwater cameras, or alignment systems, the beam is positioned precisely. Once in place, the locking mechanism is activated to ensure a secure grip on the stoplog. After verifying that the stoplog is properly engaged, the crane begins to lift. The initial lift breaks the seal between the stoplog and its slot, which may involve overcoming suction or resistance. The stoplog is then hoisted vertically, taking care to maintain balance and avoid swinging. Once it is clear of the guide slots, the crane transports it to the designated storage area or laydown platform. The stoplog is lowered gently into a storage rack, ensuring it is properly aligned and stable. This process is repeated for each remaining stoplog, typically working from the top down or as per the system design. After all the stoplogs are removed, the guide slots are inspected for debris, wear, or damage. The entire operation is then documented, including any observations or incidents, to maintain proper maintenance records. Throughout the process, safety remains the highest priority, with all personnel following communication protocols and wearing necessary protective equipment. The stoplog removing process begins well before any physical action is taken. It starts with a deep understanding of the hydraulic structure, where the stoplogs are installed. These stoplogs are large, often rectangular steel or aluminum blocks that are used to control water flow in structures like dams, canals, spillways, and gates. Their main job is to temporarily hold back water to allow for maintenance or inspection of gates and other submerged components. Because they directly face water pressure, their removal is a task that demands planning, precision, and complete adherence to safety procedures. The very first stage involves a visual and technical inspection. Operators and engineers evaluate the current condition of the stoplogs, their guide slots, and the surrounding structure. They need to know how deep the water is, how fast it's flowing, and how much pressure is acting on the stoplogs. All lifting equipment such as cranes, lifting beams, locking devices, and even bolts and hooks are examined for any sign of wear or failure. Engineers also check weather conditions and assess whether it is safe to proceed with a lifting operation. A sudden gust of wind or a shift in current can turn a routine removal into a hazardous situation. Once the initial preparations are made, the gantry crane or mobile crane is moved into position. This crane rides along rails built into the top of the dam or water control structure. Suspended from the crane is a lifting beam, specially designed to fit into the top of the stoplog and latch on securely. This lifting beam could use mechanical claws, hydraulic arms, or magnetic connectors, depending on the stoplog design. The crew communicates constantly using radios or hand signals as the beam is gently lowered toward the stoplog lying beneath the water's surface. Because stoplogs are often submerged, visibility is a challenge. In murky water, operators may rely on underwater cameras, sonar imaging, or electronic position indicators to help align the lifting beam with the stoplog. Once the beam makes contact with the stoplog, the locking mechanism is engaged. The crew ensures a firm grip has been achieved. At this point, everything stops for a moment while the team verifies that the beam is securely attached. This moment is critical because lifting a stoplog with a loose connection could result in equipment damage, structural failure, or even injury. Once the grip is confirmed, the crane operator slowly begins lifting the stoplog. Because these structures are heavy and tightly fitted, there is often some suction or resistance at first. A slow, steady pull is applied to break that seal. As the stop log begins to rise, crew members keep a close eye on its balance. If it tilts or wobbles, the lift is paused and corrected. The stop log is lifted vertically all the way out of the guide slots until it is completely clear of the structure. With the stop log in the air, the crane then moves it laterally along the deck of the structure to a nearby laydown area. This might be a set of metal racks, a concrete pad, or a series of custom supports designed to hold the stop log securely. Once the stop log is in position over the storage site, it is gently lowered into place. Workers check to ensure it sits properly and does not bend or lean in a way that could cause damage or deformation. The lifting beam is then released and moved back to the original slot to repeat the process for the next stop log. As each stop log is removed, the water pressure behind the remaining stop logs increases slightly. That's why the team closely monitors structural responses and pressure gauges throughout the process. Sometimes, if the pressure becomes too high, removal is paused and water levels are adjusted through auxiliary sluices or gates. After all stop logs have been removed, the now empty guide slots are inspected. These slots are integral to holding stop logs in place during normal operation, and over time, they may accumulate debris, silt, or even suffer wear. Technicians use tools to clean and assess the slots. If needed, they document areas that require repair before reinstalling stop logs in the future. Throughout the process, safety remains the top priority. Team members wear personal protective equipment including life jackets, hard hats, gloves, and safety boots. Emergency rescue gear such as life buoys and throw lines are kept close at hand. The crane operator maintains constant communication with the ground crew, and a dedicated safety observer watches the entire operation, ready to act in case anything goes wrong. In older or heavily used systems, stop logs may become stuck due to corrosion, silt, or deformation. In such cases, the lifting beam alone may not be enough. Divers might be deployed to inspect the stop log manually and help dislodge debris. Hydraulic jacks, vibratory tools, or heated water jets can also be applied to loosen the stop logs before lifting. Each of these techniques is planned in advance and executed under strict supervision. A full report is prepared. This report includes photos, inspection records, pressure readings, weather conditions, equipment performance, and a log of the entire operation. These documents are used not only for maintenance records, but also for training new staff and planning future stop log operations. The stop log removal process, though seemingly straightforward, is actually a delicate balance of engineering, teamwork, and safety. It is a routine task in the life of hydraulic infrastructure, but one that demands respect for the forces of water, gravity, and human judgment. When done correctly, it allows for the maintenance and continued reliability of structures that communities depend on for water management, energy production, and flood protection.